Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is pseudo-palindromic paths in a binary tree. Given a binary tree where node values are digits from 1 to 9 and a path in a binary tree is said to be a pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. That is, a pseudo-palindromic is one when we say if there is a root to leaf path, then if this is a palindrome, then we can say it is a pseudo-palindrome. Return the number of pseudo-palindromic paths given from the root node to leaf nodes. That is, the 233 is not a palindrome. 233 is not a palindrome. They are saying if there is existing a root to leaf path, if their permutation, we can change this set of numbers into a permutation of 323, and if this forms a palindrome, so this is a pseudo palindrome. So 233 is forming one palindrome and 211 is also forming another palindrome. So there are the two pseudo palindromes here. So how we can do is, we have solved several problems like finding the root to leaf path, like that. Those techniques can be used here, but what is the challenging part is how we are going to form that permutation such that they are going to be a palindrome. Let us take a palindrome string, or I will say it as 1 1 2 2 3 3. So this is one such palindrome. This is one such palindrome with even length. This is one such palindrome with even length. And we can take some odd length palindrome. Odd length palindrome is 1 1 2, then sorry, this is not actually palindrome. It will be 1 here, 1 here, 3 here, 3. Yeah, this is a palindrome. Now we can take an odd length palindrome 1 3 2 3 1. So this is an odd length palindrome. How we can say this is a palindrome is, this is, if it is an even length palindrome, then we know that for each and every character those those number of frequencies should be divisible by 2. That is, all the frequency should be divisible by 2. And if this is an odd length palindrome, what we can do is only the center number should be having a frequency 1, or else it can be a odd number of frequencies. Even this is an odd length palindrome and their frequency, 2's frequency is 3, so it is an odd number frequency, and 3's frequency is 2 and 1's frequency is 2. So if we take their frequency, if those frequency we have only one odd divisible frequency and others all even numbers, then we can say that it is also a palindrome. So these are the cases: only one, strictly only one odd divisible frequency should be there, and others all even divisible by 2. So this is one such thing that we have to consider. These are the two cases that may occur for palindromic to be a palindrome. So since they have given the values in the node will be ranging from 1 to 9, that is even more giving us a even more easiest way to find whether it is a palindrome. We can just traverse I from 1 to 9 and check whether their frequencies are divisible by 2, and if there is an odd number, it should be having only one time, and if it is so, then we can say whether that is a palindrome or not. Now this is okay, but now how we are going to generate this? So obviously we know that by doing a root to leaf node, we can go for one traversal, either pre-order, post-order, or in order. Any other traversals we can go. So what we are doing is, we can have a map of size 10. This 1 to 9 values can be updated here. In this, whenever we are at root, we will be incrementing their values. Initially it is 0. And now actually MP of 2 is 1, and after which we will tend to go for its left. While going for its left, we will go and increment their frequency. MP of 3 becomes 1, and we will go for its left. MP of 3 becomes 1, and as we know that this is a leaf node. Since this is a leaf node, what we can say is we can call some function that is going to check whether that is a palindrome or not with this frequency array. So if we pass this frequency array, if that function is going to return me a 1, then we can count that to be a palindrome, or else we don't want to count that to be a palindrome. And then after processing this, we go back. While we go back, we want to decrement this frequency. So now MP of 3 is already 1. I should increment it as 2. Sorry. So okay, now we are at this 3, and while going back, we have to decrement this 1, by 1, so it becomes 1, and we tend to go for its right. While going for its right, we tend to put MP of 1 equal to frequency 1, and now again we will call the function with this MP array, and whether if this is a palindrome, it will return 1, else not. And finally, what we are doing is we can just return a count. So we will write a recursive function by using the post order traversal. Why is post order traversal? It is not specific that post order traversal. We will just increment our frequency before passing to its left, and we will decrement our frequency after going and processing to its right. So we can write a function return solve, or I can say as count palindromes of root. I have passed the root. Now I will write a function in count palindromes, and I am taking the parameter as root. Now we can write a base case. If my root is null, I am just returning 0. If this is a leaf node, if my current node is a leaf node, if my root of left is also not present, leaf node. If this is a leaf node, if my root of right is also not present, this is a leaf node, then what I can do is, first I have to include that value, include this value to our frequency. I actually want to pass this MP array as well. I will declare a MP array of size 10 and initialize it to 0 initially. Okay, now we have to take this val, MP of root of val plus. We will be incrementing this. After incrementing, we have included this node. After including this node, what we will be doing is we will have a flag variable that is going to check and say whether this is a palindrome or not. I will let not declare this function. I will name that function to be check palindrome, and I will pass this MP array. That's it. If this flag after passing and coming, we will be getting either 1 or 0 from that function. After which we have to decrement our root of val as well. We will decrement it. If my flag is 1, return 1, or else we will be returning 0, so that we can just return flag itself. Okay, now I will declare a count variable which is 0 initially. Now whenever I come inside, we are at this node. Whenever I come inside, I have to increment that node with my map, MP of root of val plus. After incrementing in my map, I will go and search for its left path. So I will call plus equal to count palindromes of root of left, and I will pass MP array. And after coming back, I want to go for its right, count palindromes of root of right, and I will call this, I will pass this MP array. After coming from this, I have to decrement my root of val in my map as well, because I am backtracking. I have incremented this, I have incremented this, I have incremented this. While going back, I will decrement this. While going back, while going through to its right, after coming back, I will decrement this 3 and then only I will go for its right. So if my map is having this 3, then it may be conflict. So I should decrement that val. After which finally I am just returning my count variable. So now we will declare this function check palindrome. It is a boolean type and check palindrome, and I am taking a MP array as my parameter. As I have said that we can have a flag, bool odd flag, which is initially false. I will go from int I equal to 1, I less than or equal to 9, I plus plus. If my MP of I is odd, if my MP of I is odd, how I can check? With bitwise and with 1 I can check whether it is an odd or not. If my MP of I ampersand 1 is going to give me 1, it is going to be odd frequency. If it is an odd frequency, only once it can be. So I will make this odd to be true. But again, when I have an odd number, if the odd is already true, if my odd is already true, then I have two numbers. Then I have two numbers which is having a frequency with an odd value. So in that case, I will return false. Hope you understand this. Hope you understand this. If there is an only once, it becomes odd, becomes true. If again there is an odd value comes, then if my odd is true, then I am just returning false, since I cannot make a palindrome with making use of that. Or else finally I am just returning true. That's it. This will definitely give me whether it is a palindrome or not with their frequencies. Hope you understand this. I will give a dry run. I have declared an MP array and initialized with 0, and I am calling this count palindromes function with the root and MP passed as their parameters. After which, if my root is null, I will be returning 0. If this is a leaf node, then I want to take into account of their value, right? So I will update it in my map MP of root of val plus plus. Then I will get it in one flag variable. If this is a palindrome or not, and then I will decrement that value, and then I will finally return this flag. Since this is a leaf node, obviously this is not going to happen, where either I will return 1 or not 0. After which I have declared a count variable is 0, and whenever I come inside, I am going to increment in our map. After which I am going to go for its left as well as for its right. After coming back, I will decrement its value and move forward. So and finally I will return this count. In my check palindromes function, what I am doing is I am having an odd flag which is initially false, and I am going through for the array MP array from 1 to 9, and I am checking whether this MP of I is an odd. If MP of I is an odd, and that is the first time I am encoding an odd value, then I will make this odd to be true. And if there is another odd value comes, then then the odd value, the odd flag is already set to true, so it will return false, because I cannot make palindrome with two odd numbers, two odd frequency numbers. Or else finally I am just returning this true. Hope you understand what is my logic and implementation. Let us try to run our code. It got accepted. For let us use the example test cases as well. It got accepted. Let us submit our code. The time complexity here will be order of n, and the space complexity here will be order of h. H will be the height of the tree, and n will be the number of nodes in the tree. And space complexity, it is not that much in MP array, because it is only 10 values, but it may grow. It may use a stack recursion stack space, so that is that grows up to order of h, height of the tree. So this is what pretty much for today, and hope you like this video, and let me know in the comments. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.